125 now. A, B and C are 3 points on horizontal ground. AB is 8.4 meters and BC is 9.2 meters. B is on a bearing of 0.67 from A. So if this is A, I'm going to have to draw this here. And we go up to north. And then B is on a bearing of 67, so this is 90, so it would be about that way. Which means that this is B and this is going to be 8.4. I may regret the way I've drawn this. Now, C is on a bearing of 129 from B. So let's go up to 90. That's 90. That'd be 180, so it's about that way. Let's make that C. So bad. And that's 9.2 meters. So this, right, let's just draw this in. So that's 67. And then this would be, so this is 129. So this bit there would be 51. And then this bit in there would be, what's 67 from 180? 113. So this bit here would be, oh, for goodness sake, 113 plus 129 plus 51 equals 293, so that's 67 in there. And the whole thing, therefore, is 67 plus 51. So that's 118 around there. Okay, I think that's important for a minute. Calculating the bearing of A from C, oh God, so that is this. So you've got to go all the way around and up that way. So, yeah, we know that's 118. I don't know what that is. I was going to find out how long that was by using the cos rule. And if you do that, then we can use that to find out what that is. Oh, that'll do. Okay, so we're going to use the cos rule. So A squared equals B squared plus C squared minus 2BC cos A. So that equals 8.4 squared plus 9.2 squared minus 2 times 8.4 times 9.2 times cos 118. And then we'll square root that to find out what A is. I wonder if I can do this all in one go. It's bound to go horribly wrong. 8.4 squared plus 9.2 squared minus 2 times 8.2 times 9. It would help if I'd done 8.4, wouldn't it? 8.4 times 9.2 times cos 118. Close that bracket and hope this works. Okay, so this distance here is 15.0917. Okay, so we know what that is. Now we can use this to find this one here and this one here. In fact, let's use it to find that one there. And the way we do that is we say, okay, sine of 118 over 15.091, whatever that is, equals, let's go for that, sine of x over whatever that is, 8.4. And then it would be 8.4 sine 118 over answer equals sine of x. So that is going to be, let's do this. So it would be 8.4 sine 118 over answer equals, okay, now I've got 0. So sine of x equals 0.49144. So that means it's going to be very close to, I don't know, 30, I think. So that would be, now let's do the inverse. What is it? Answer equals 29.43. So this bit here is 29.43. So therefore, if you take that away from, that doesn't completely work, because I don't know what this one is here. And how would I find that out? I can find that out, hang on. I can find that out, because that's 129. So if that's 129, that is 51. So now add 51 onto that, and you get 80.5 or 80.43, and then take that away from 360, and that gives you 279. So it's going to be the bearing of A from C is equals 279. How far do I have to be going? To the nearest degree. It's 280 degrees. I hope that's right. There is so much room for going wrong with this. That's what's hilarious. It's 6 marks. Right. This shows an equilateral triangle, ABC, with circle and a circle with centre O. So they're all tangents to the circle. The radius of the circle is x, and the total area in centimetres squared of the regions shown is nx squared. Find the value of n and give your answer to 3 significant figures. Now this isn't that easy, but there is something you can do. So what I'm going to do is I'm going to draw this in here. Okay. Now, one thing that I've just done is I've made that bit 1/6 of the triangle, but I've also made it 1/6 of the circle. So I can just use a proportion of that to work out the rest. Now, I also know that this is 30 degrees because it's half of a, what's the word? It's half of the angle in an equilateral triangle. So I'm going to pretend x is 1 because I don't, and then I'm going to find out what this side is based on that. So if I make this 1, what is this? And this is 30 degrees. So I can use those two. I can say tan of 30 equals 1 over y. And we know what tan of 30 is because it's an actual thing. It's, I mean, everything is an actual thing, but it's got a nice, it's √3 over 3. So we know √3 over 3 equals 1 over y. And that means that y would equal, we can times that up, so √3y over 3 equals 1. So √3y equals 3, and y equals 3 over √3. Now I know I'm not meant to leave that like that, but I don't care right now. So what I now know is that that bit is 3 roots over √3. So far, in this little, in the 6th bit of, or rather a 6th of the triangle and the circle, I know that the half AB, this bit here, is 3 over root 3. And I'm not going to sort that out because I don't want to. So what I'm going to do is, pretending x is 1, I'm now going to just work out what the area of this bit here is. And I'm going to do it like this. In terms of the triangle, I'm going to say 1 times 3 over root 3 times a half. That will give me the whole of that little bit of the triangle. So all of this bit, right? Okay, but I know I'm not really allowed just that bit. I've got to get rid of the bit in the middle. So now I'm going to go minus 1 squared pi, and this is going to be 60 because it's a sixth of the, because we know that it's a sixth of that because it's 30, 60 and 90. So that's basically pi over 6. And then I'm going to put this into my calculator and see what I get. So I get 3 over root 3, and please ignore the fact that this isn't a very correct thing to do, but I can't be bothered right now, times 1 over 2 equals, and then we're going to go minus pi over 6. Let's shift pi over 6. And that gives us 0.3424266, whatever it is. But basically that means this bit there, right? And that bit is replicated here, 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 and here. So if I times this by 6, my answer by 6, I get 2.054559. But the point being, to three significant figures, it's 2.05. And that is what n equals.